All right, in this video, we're going to go ahead and work on another formula, work with another formula that utilizes radian measurements and uses it to calculate area of a circular sector. So we worked on arc length in the previous video, and so now we're looking at area of a circular sector. So first and foremost, we have our circle, or the best that I can draw, with a radius of r. And then if we cut out some section of that circle with a certain angle, theta, what we can do is we can evaluate the area of that piece by using the following formula. So you can find the area of that circular sector from the formula 1/2 r squared theta. A big thing to note is that your theta, your angle measurement, has to be in radians in order for this formula to work. And so the A stands for area, the R stands for the radius, and then the theta stands for your angle measurement, where your angle is 100% measured in radians. And so if I give you a problem with this formula or with this problem setup, I could give you any two of these variables and you would be expected to be able to find the third, whether you have to solve for it or whether you just have to plug everything in your calculator. So let's look at these first two examples. So in the area of a, we're going to find the area of a circle with central angle 60 degrees and radius 3 meters. So we have a circle. It's got a radius of 3 meters, and then we're looking at a chunk of that circle cut out at 60 degrees. And so the first thing that we have to do in order to evaluate this area is we have to convert our degree measurement, 60 degrees, to radians. So we multiply by pi over 180, and that is the radian measurement, pi over 3. And so then now I can use my formula, 1/2 r squared theta, and I can plug in, I don't know area, I can plug in my radius, which is 3, my angle, which is pi over 3, because we're writing it in radians, not degrees, and then you can go ahead and you can plug that into your calculator, which ends up giving us 4.712, and then this is area, so it's your units squared, meters squared. All right. In the next section, we have the area of a sector of a circle with central angle 150 degrees, and they're telling us that the area is 12. So basically what they've done is they've given us a circle. They say that we're measuring this chunk of the circle, which has an angle of 150 degrees, and they're telling us right off the bat that the area of that circle is 12 already. So this one's a little bit weird because they don't give us the radius and the angle measurement. They give you the area already, and then they want you to solve for your radius. Before we do that, though, we should convert our degree measurement to radians because, oops, we can't use this formula unless it's in radians. And that is 5 pi over 6. And then now I can plug in the things that I know. So I actually, when I'm looking at my formula, I know this area already for this problem. So I have 12 equals 1/2. My radius I don't know, so I'm going to leave that as an r. And then my angle measurement is 5 pi over 6. Beautiful. And then we're going to solve for r. So the first thing I would recommend doing is multiplying the 1/2 and the 5 pi over 6 together. And so you can think of that as 5 pi over 12 times r squared. And then to solve for r squared, to get r squared by itself, we have to divide both sides by 5 pi over 12. Be careful when you do this because you want to divide by that whole fraction. So when you actually go to plug it into your calculator, do 12 divided by the fraction 5 pi over 12. Oops. So put that fraction in parentheses, okay? So then we'll get r squared equal to 12 divided by, 5 pi divided by 12. Close parentheses, I get 167. And then to find regular r, we need to square root both sides. So then you get r equals 3.028, and then our area was in centimeters squared, so our radius is just centimeters. Awesome. All right, let's look at our next example. So area of a circular sector, and now we have a system that's set up for us. So we have an irrigation system. An irrigation system is what's used to water crops in the and farm fields. And so an irrigation system uses a straight sprinkler pipe 300 feet long that pivots around a central point as shown due to an obstacle. So it looks like a rock outcropping or something like that. That pipe is only allowed to pivot through 280 degrees of the circle. We want to find the area, so this green area that's irrigated by the system. So if we were going to draw our own picture for it, it looks something like this. We'd have the 280 degrees is this whole section. This is 300 feet, and then we would be calculating this whole area. Okay, so first and foremost, we go ahead and convert our degree measurement to radians because we can't use this formula unless it's in radians. And when you do solve this one, you do 280 in your calculator divided by 180, and you kind of leave the pi out of it. And then you find the reduced fraction form by hitting math, enter, enter. So 280 over 180 reduces to 14 over 9, and then your pi is still there. And so now we're finding the area irrigated by that system. So we use our formula where your radius is 300 feet, so we'll have 300 squared. Your angle is 14 pi over 9. And when you plug that all into your calculator, we get, let's see what we get. You get 219,911.486, and then the units for this would be feet, so feet squared. It's a big area. All right, last but not least, we have the windshield wiper blade setup. And so it says the top and the bottom of the windshield wiper blade are 34 inches and 14 inches from the pivot point, so where it's attached to the car, respectively. If you have a car or you've changed wiper blades or you're familiar with what wiper blades look like, you know that the rubber part of the blade doesn't actually go all the way down to the car. It stops, and then there's where you fasten the blade to the car. And so we want to find for us the area that's actually being swept by the blade. The blade only goes 135 degrees in both directions. And in this scenario, you have to take into consideration that the only part that's actually being swept by the blade is this part that's right here. Right? It's missing this little chunk at the bottom. And so what we're actually going to do is we are going to take the whole large section that's being swept by the blade, right? So there's your 135 degrees, and then that is 34 inches. And we are going to end up taking out this chunk that doesn't actually have rubber on it because your wiper blade doesn't actually wipe off that part of the car. So that's 14 inches long. And so we're actually going to end up finding two areas and then subtracting them so that way we can find just this area up here. So we'll take the big area, we'll subtract out the small area, and then we'll be left with what your wiper blade actually wipes off. So first and foremost, convert our degree measurement to radians. So we multiply by pi over 180 degrees, and you end up getting the radian measurement 3 pi over 4. And then we'll find our big area. So I'll do that first. Well, second, I guess, since this was our first step. So A equals 1/2 r squared theta. So your area is 1/2 times the big radius, so 34 squared theta, which is our angle measurement, so 3 pi over 4. And we end up getting, when we do that, 1/2 times 34 squared times 3 pi over 4, 1,361.880, that would be inches squared. And then we're also going to find the smaller area that's in here, and then we'll take the big area minus the small area. So we'll still have the same formula, it's just that your radius is going to be different for this one. So we get A equals 1/2 times the smaller radius, 14 squared, and then my angle measurement is 3 pi over 4. And so then if I plug that into the calculator, I think you should get something smaller. I get 230, write this over a little bit more, 230.907 inches squared. So then to find the area that's actually covered by the wiper blades, which is just this crisscross area up here, you have to subtract them. So I'll do 1,361.880 minus 230.907. And I end up getting 1,130.973 inches squared. And that would be your final answer. All right, let me know if you have any questions.